Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today live with episode number 58 of Shop Talk. And are you guys ready to rumble? Because we got some great stuff in store for you today. Let's see if we've got some people coming into the live stream. It looks like we've got Larry. Welcome, Pascal. Scott. Looks like we've got VR in the house. I think I saw Vaughn earlier. Hello, Roshan. Brian, always good to have you. I understand for you guys it's a little bit too late for coffee maybe, but hey, I am right in my prime coffee season. And what I will show you is this morning I will be sporting a most excellent cappuccino. I make my cappuccinos not with milk, but with whole whipping cream. And if you want the best coffee ever, get whole heavy cream and then steam that and then pour your espresso on it, and you have got the breakfast of champions. No sugar, no sweeteners, none needed. But also because this is like, I had to get up at 4 o'clock in the morning, and now it is 6 o'clock. So I've been trying to get ready for this live stream here, get the studio all set up for the last 2 hours. And so I thought I better have some supplementary caffeination. So I do also have my traditional iced coffee. Straight up black coffee, poured over ice, no sugar, no sweeteners, none needed. Iced coffee, you make it hot and then you pour it over ice. Now, what you have to do is you have to make it really strong, because when you pour the hot coffee over ice, the ice is going to melt and dilute the coffee. So that's kind of part of the deal. So what I like to do is I like to make 2 shots of espresso, pour it, that's a small amount of coffee, but then when you pour it over ice, the ice melts, and then you end up with a nice tall glass of very robust and strong, yet still mellow and delicious coffee. Okay, so we've got Vaughn in the house. It says, Vaughn, so you do drink coffee at night. Okay, some people can do that. I usually cut my coffee drinking off about 1 o'clock or 2 o'clock. Okay, Jesse likes my haircut. Man, this is like the worst haircut I ever got in my life. And I love the people here in Africa, but they don't know how to cut old white man hair. And that poor guy cutting my hair, he just kept cutting, and like the longer he went, the worse it got. And it was like too short on the bottom. So then he like moved it up. And he spent an hour and a half on this thing, and he really botched it. But you know what he did? Like after it was all over, he kind of felt bad. He sort of gave me a tube of holding gel, thinking maybe if you just paste it down. But anyway, I am not a slave to fashion, so a bad haircut is okay. Hey, Brian's having some orange juice. All right. Oh man, Brian, head cold. Hate to hear that. Hit those old supplements, vitamin C, vitamin D, get those supplements going there. I hate it. I hate the old head cold. Yeah. Pascal, is it dual coffees or is it dueling coffees? Okay, dual coffees or dueling coffees. Okay, looks like, let's see. Hey, we got FJL05. You could, it is, trying to get this hair fixed is about like trying to get a print to stick to the 3D print bed. Okay, we got some more people coming in. Invalid X, good to see you. Okay, good to see that we got some people coming in. All right, what are we talking about today? We are talking about 3D printing, and we are talking about why most 3D printers end up in the abandoned project corner of the old shop. So let me know, you guys, if you have ever abandoned a 3D printer in the corner of your shop. I want you to leave a comment in the chat, a comment GAC. What does GAC stand for? Guilty as charged. Okay. How many of you guys have ever left a 3D printer abandoned in the corner of your shop? I will have to say I've done that, and I've done that on multiple occasions, and I just got to where the 3D printer finally just wore me down, and I put it over in the side, and I kind of rued the day that I'd ever bought it. Okay, Yash is agreeing. All right, sounds like I'm not the only one. Okay, Brian, all right. Hey, but Brian looks like he's trying to resurrect his printer from the dead, and so that is really good. Well, I want to talk about that today, and I want to kind of talk about maybe some things we do. If you've got a dead printer, maybe we could try again. And sometimes just understanding what's going wrong can help you have more success. And we could cover these topics in detail in a lot of different videos. But what I want to do today is I want to just sort of hit the high points of what I see that's going wrong. Hey, you guys like my print that I'm going on live? We are printing live, and that is a pretty scary thing to do. But I am printing a most ginormous nut and bolt. You can see that it's a really big plastic nut and bolt. And, you know, guys, it looks like maybe I have one more layer and the nut will be finished, and then it will come on up with the bolt. Hey, Naeem Huck came in. Welcome, Yash. Welcome. Looks like we got some guys coming in. How do you like that print? Is that a pretty cool print? Pretty neat print. For some reason, I love printing nuts and bolts. It's just I like to have something that operates like that. So I have a lot of fun printing nuts and bolts. And also today, with a little luck, and if you guys will remind me, we will try to be watching a sunrise over the old River Nile as I am sitting here on the banks of the mighty Nile River. We should be able to catch a sunrise, maybe see some fishermen out there. Right now, it is, for me, 6 minutes after 6 a.m., and the sun will be coming up precisely at around 6:30, so maybe a little bit before that we could see the sunrise. But in the meantime, we will come back over here to the most excellent printer cam, and then I've also got sort of a view over my shoulder. If you want to see that, you can see this the Dueling Coffees over here, and then I've got the combo shot where you can see the over the shoulder and then the close-up of the print. Hey, we've got Sebastian coming in. That's good. It says, how do the threads hold up? Let's see. Depends on what you're trying to do. If you are trying to bolt a wing on an airplane, I would not recommend using 3D printed bolts. But as far as just excuse me, little simple projects and fun things around the shop, they last and they're really good. Yeah, if you're concerned about them not lasting, you can kind of thicken up those sidewalls a little bit. But I've had really good luck with these plastic 3D bolts, and I've kind of nuts and bolts, and I've kind of had a lot of fun with that. Okay, so I guess this is enough chit chat. We've got people coming in. Let me jump in and kind of talk to you about why I think that most 3D printers that people buy end up in the abandoned project corner of the shop. And the number one reason is the failure to realize that 3D printing is a skill. It is both a science and it is a craft. It is a skill that you develop in order to be able to print nice 3D prints. And when people hear the word printer, they think of their HP laserjet printer. And what do you do with that? You plug it into the wall, you plug it into the back of your computer, you press print, and it does whatever you want. And so that's what you think of when you hear the word printer. So when you think of 3D printer, when you hear 3D printer, you think of that same type of thing. You think that you are going to plug it in, and then after you plug it in, you just draw something and then it prints it out. Not so, my friend. It doesn't really work like that. And really, this is what I would say is usually more like the typical experience that people have with a 3D printer. And that, well, let me say this. Okay, so the first thing that I say is that printing is a science and a craft. It is a skill that you develop over time. It is not plug and play. It is not press the go button and then watch the thing happen. It is a skill that you have to develop. And people fail because they try and print a model with a size and complexity beyond their skill set. Okay, printing prints with size and complexity beyond your skill set. So this is the typical scenario. Okay, this is a typical scenario. You buy a 3D printer, and it comes with a little SD card. You turn it on, you put it together, you turn it on, and then there's a little demo print, maybe something like a very small nut and bolt, or a little geared widget, something very small, very simple. You press print and you watch it, and it's like magic. It's like magic as that thing begins to move around and begin to print. And then some hours later, you have this marvelous thing, and it's like the greatest thing that ever happened to you in your life. And you look at that little thing you made, and you just imagine that your future is going to be different. It's like your life has changed and the world has changed because you got a 3D printer and you can do this. Okay, now what is the next thing you do? So you run out to Thingiverse, and what you find is a 3D model for a jet engine from a Boeing 747 that's this big and this wide and has 2 gazillion intricate little parts in it, and you hit download and then you hit print. Okay, and then what happens is, it's a long print, you go away, and when you come back, the print has peeled up from the bed, and your printer has made this horrible huge glob on the bottom of the extruder, and then you like spend a week trying to get that glob off of your printer. You break some wires, you get this, you get that, and it just kind of turns into a nightmare. You then sort of get the printer working again, and then it never does quite print things right, and so it's sort of like, and then you try to get it working and you can't get it working, and then you just get sick of it and throw it into the corner. Okay, what 3 mistakes, or there were multiple mistakes that were made in that scenario that I think happens to a lot of things. Number 1, you are printing something that you didn't design. Number 2, you are printing something bigger than you have the expertise to print. And number 3, you are printing something taller than what you have the expertise to print, and something with more complexity than you have the expertise to print. So the first key to success in the world, of 3D printing is number 1. And if you don't learn anything else today, this is important. Number 1, only print what you have designed. Only print what you have designed, and design simple things to start. So when you start, you're probably not a design expert, and you're not a printing expert, and you are not a printer expert. So start with a simple design. Why? A simple design is easy to print. Okay, a simple design likely will not have design errors like STL errors in it, and it is easy to print. And then what you got to see is, over time, you're going to do 3 things. You're going to improve your design skill. As you improve your design skills, you can design things that are a little more complicated. As you do that, you are going to improve your printing skills. Okay, so as your design skills improve, your printing skills improve, and then as your printing skills improve, you are also going to improve your printer. You're going to do tweaks and adjustments and maybe even upgrades to your printer. Okay, you can, Vaughn says filament spaghetti. Yeah, how many of us have gotten that? But what you're going to do is you're going to move forward in an organized and logical way, improving your design skills, improving your printing skills, and improving your printer. And if you will do that in little small steps, you will one day be able to print those really complex things. But again, do not download things from Thingiverse. And like what my rule was when I was teaching in a high school with high school students, my rule was if you wanted to use the 3D printer, number one, you had to design the thing yourself. You could not find something cool on Thingiverse and come in and want to print it, because number one, you haven't learned anything. Number two, you're probably going to mess up the printer. And number three, when you mess up the printer, you're going to sneak out of there and leave the mess for me to clean up. So that was always a rule that I had in school. You only print things that you have designed. And I think that is a pretty good, idea for all of us. Okay, let's see. Looking at the, hey, Opal, welcome. Wonderful to have you here. Okay, it sounds like, it's Opal says it was a similar experience with trying to make a PCB. Yeah, I know what you're talking about there. PCB is also something, making a PCB yourself is something that is also both a science and a craft. But I think I will take a little swig of coffee here. As we are looking at our nut here, I think we are getting close to the last level of the nut. I think we are kind of closing out that top level of the nut, and then it will continue to work as it comes on up with the bolt. Daniel, welcome. We are going to need a tardy slip, Daniel. This was a very, very important day, and you are tardy. You made it. You made it late, boy. Okay. All right. So let's keep going here. Let's take a look over at the river cam. Yeah, still very dark over there, so we don't see a lot going on out there. But what I want to talk to you now about is, so I've talked a little bit about why 3D printers end up being abandoned over in the over in the back of the corner of the shop. Conservative is asking, are you back in the United States? No, man, I'm sitting on the banks of the River Nile in the jungle in Africa. And hey guys, I want to show you something here. Want to really thank you guys that are helping me out over at Patreon. I want to show you guys, I have been able to upgrade my internet, get more of like a direct connection. Instead of having to operate over the cellular network, I have like a radio that goes back to the tower, and look at that. Living in the jungle with a 48 megabit download. Pretty good, huh? That is a pretty good connection. And these are hard to get and they're expensive. And so you guys that are helping me out over at Patreon are really making that possible. And also kind of the reason that I have not been doing live streams in a while, is just that my internet connection was too spotty and too intermittent. And therefore it was just too stressful to try to do a live stream with unreliable power and unreliable internet. My power is still unreliable, but what I have started doing is, like, before the live stream started, even though I had grid electricity, I had them cut the grid and then turn the generator on. And so right now I am operating on generator. And so whatever the grid does, we should be able to stay up with the generator. And so with the generator and with the fast internet, I should be able to do live streams again. If you guys are interested, I don't know, maybe you guys aren't interested. Let me know if you enjoy the live streams. Let's look at some of the comments. We've already scolded Daniel for being late. Okay, yeah, I think you're right, Pascal. The things that I'm talking about are good in general. You start small and you move forward incrementally and you improve yourself and you improve your skills. That's pretty good in just about anything. Okay, let's see. Okay, Mrs. Sains called in for him. Yeah, we got a call from your mom, Daniel, saying you were late. Okay, you were going to be late. Okay, Kaziru says he loves it. Great. I have faster internet than XValid. Okay. Where do I get those overhead cameras? Well, let's see if I can't really show you, but what I have is I have a studio camera that's a very high resolution professional Sony studio camera over my shoulder here. Okay, over my shoulder, I have that, and that's what's giving you this shot. Then this shot, unfortunately, is just a Logitech webcam, which is not high resolution. And then the camera that is shooting me is high resolution, so Canon studio camera, and then out the window, looking at the river. Hey, we're almost starting to see a little signs of light there. You can see the palm tree, you can see the river, and you can see the lights back in the background. But it seems like there's not enough light for that to focus. But that's a very high resolution camera as well. Okay, so River Cam, the studio Canon camera, and then I've got the over the shoulder high resolution camera. That's 3. And then also I have to be able to do screen captures, like off of the, or I have to be able to stream from the HDMI output of something like the Raspberry Pi or the Jetson Nano, so that you can get crystal clear images of that. So that's 4 high resolution HDMI inputs that I need into my computer. I have a Blackmagic quad HDMI input board in my computer, so I can input those 4 high resolution streams. But you can see then what the problem is that even though I have a camera, I don't have a port for looking at a close-up here. And there's really not a solution to that, because I don't have, you just can't cram that much HDMI data into a computer, and so that's kind of what I'm limited with. And then what I just do is I use a webcam for this. The other thing that I have that we'll be looking at in a minute, because I'm going to do some sketches for you, is from Sketchpad. When I'm drawing things, that is another needed HDMI port. And so what I do is the Sketchpad and the River Cam share a port, and I have a little switch that I can just switch between those two into the into the back of the camera. But I digress. Let's look at some more comments. Okay, Brian enjoys the live streams. Colin enjoys them. Opal enjoys them. Great. Hey, Von's giving us a report here. Hey, it looks like we got 84 people doing. We got Von helping us out today as a moderator to keep things clean and family friendly and keep people from being a nuisance. Looks like we got a good crowd though today. Really good crowd. Sometimes kind of like you get a troublemaker into the live chat and it's just like, man, just kick them out, right? Because life is too short to deal with toxic people. Okay. Would you recommend your chair? Okay. You're talking about the chair that I'm sitting in. The chair that I am sitting in is an Aran office chair. It's really a quite expensive chair, but I bought one back in about 2000, and that darn chair lasted me 20 years. And then finally it started getting a little bit needing replaced. So I bought a new Aran chair. This is my second Aran chair, but it adjusts in like 57 different ways. And if you're sitting for a lot during the day, I definitely recommend a nice office chair. Okay, let's see, Ryan. Good. Hey, it is very early morning here for me. In fact, we'll take another look at the River Cam and see. We're starting to get a little focus there. Look at that. Okay, I lied. I said that was a palm tree. It's not a palm tree, but you can see the mighty River Nile behind me there. And this is really like right at this is the headwaters of the River Nile. And in fact, if I go down to the edge of my property and look, I can see right there where the Nile starts. So I am sitting at the source of the River Nile. What's printing? I am printing a ginormous nut and bolt, which will be functional. You can see here that the nut is finished and the base of the bolt is finished. And now it is putting the threaded part of the bolt on there. Let's come back to the River Cam. Have you ever thought of making podcasts? Not really, because I love the video aspects of things, and just kind of sitting and talking without showing anything is just sort of not the way that my head works. Scott likes to tune in when he can. The opposite of handwriting. Let's see, how many sensors in Arduino? That really depends on the sensors and really depends on the software. yeah, what's printing in the background is the nut and boat. Yeah, let's see, it's still dark, but it is beginning. This would be considered dawn at this point, and pretty much dawn is at 6:30 in the morning and dusk is at 6:30 in the evening every day because I live on the equator. Okay, yeah, okay. Webslinger is talking about problems with STL files, and that's one of the things we're going to be talking about today. One of the things that we're going to be talking about today. Have you ever done any fishing in that river? Man, you know what? I tell the people on my compound, there's like probably, I don't know, close to a dozen people on my compound. And you know what I say? I say, I'm living on the river. I'm not eating fish. What's wrong? Why aren't we sitting here eating fish every day? And there are tilapia in the river, but these aren't your old store-bought, tank raised factory tilapia. These are the real original tilapia, the heirloom tilapia, the tilapia that all the other tilapia came from. And this river is loaded with tilapia. Okay, and then also there is a fish called the Nile perch. Now, like if you're from Texas or from the U.S., you think of the perch as a little fish that's kind of like the smallest of fish that you even bother with here. But the Nile perch get like 4 feet long and weigh like 100 or 150 pounds. And so the Nile perch are out here as well. And sometimes I see the guys out in the boats, I see them catching those Nile perches, but usually they just come out with just strings and strings of the tilapia, and the tilapia are about this big. So yeah, I need to get a little fishing operation going on out there. Let's see. Haven't done any fishing. Hope you guys don't mind me just chatting with you a little bit. I like to interact with you, and so if you're wanting to get to the meat, I'm sorry, I do enjoy spending a few minutes talking to you. Does it get hot here? No. In the nighttime it's about 65. In the daytime it's 75. And so the cool thing is I don't have to have a heater. And then the cool thing is I don't have to have an air conditioner. It's just every day is very, very pleasant. And if there's a day that's a little hot, there's a breeze coming off the Nile, and so all day I just have a cool breeze if it's a hot day. And I have windows and doors facing the river. I just open them and the house stays cool. And then at night, really I don't need a blanket. What I find is maybe in the middle of the night I reach and I pull the sheet up, but it's like pretty much ideal weather here. Okay, let's see. On my 3D printer, one of the steppers has started vibrating badly and messing up my prints. Okay, one of the things that a vibrating stepper motor, what it can be sometimes is that a wire coming to the stepper motor could be kind of shorting out, or you could have a problem in the driver board. Okay, in the motherboard you could have a problem, or you could have a problem with the motor itself. So there's a lot of different things, and you got to kind of just systematically troubleshoot it. And that's the thing with 3D printers, it is a lifetime of troubleshooting. If you do not have a problem with your printer today, just wait. In the next few days you're going to have a problem with it. So if you enjoy troubleshooting and tinkering, then a 3D printer is a great thing. If you don't enjoy tinkering and troubleshooting, you're going to hate your 3D printer. So let's see. We've got if one likes fish, then one lets them live. If one likes fish, one eats them. Sorry. Do you have croc problems? Actually, out here right in this area, there's not crocodiles, but in an area that I go to in the bush, there's a lot of crocodiles. And here a few weeks ago, I went out into the lake to an island. It was about a 2-hour boat ride to the island in the middle of a lake. And where this island is, there's a little place here in Africa that's like one of the most remote places on earth. It is called the Village of No Village Beyond. And if you go to the Village of No Village Beyond and you go beyond it, there's a lake. And then if you can get a boat, like I had a boat and I went out in the boat to the middle of the lake and there was an island there and there were crocodiles there. And this is kind of like a little rickety boat and you're on it for 2 hours getting to the island. I could have been eaten. Yes, I could have been eaten, but I did make it back. Okay. Let's see. Getting some nice comments here. Created a musical instrument with Arduino and a buzzer. That's good. That's always good to have a little creativity in our projects. We've got a student from Syria, Al Motazam. Al, I'm sorry I'm not saying your name right, but welcome. We love having people from Syria. Sorry that you're in a part of the world that's had a lot of pain in the last few years, but man, hold up. A lot of us wish that the world was a more peaceful place. So sorry for the troubles you guys have had over there. Okay, let's see. I have chatted with you guys enough. I should probably jump in and start talking a little bit more about 3D printers. So what I think I left off with was what you really need to do. What you really need to do is, number one, only print things that you designed. Don't run out to Thingiverse and download something and then print something that, number one, you don't have the skill to print. Number two, you didn't design yourself. And number three, might have all types of hidden STL problems or errors that then cause your print to fail and can damage or misalign or cause all types of difficulty in your printer. So the biggest thing is to print simple, take small steps forward, and improve your design skills, your printing skills, and your printer together, and to build skills slowly over time. Okay, so now what we're going to do is we're going to talk about good engineering practices, good practices that will allow you to be successful with your 3D printer. Now I'm going to have to do a little bit of, no Thingiverse, that's right, Daniel. And okay, you guys just suck me in. I can't resist your questions. Okay, I can't resist your questions. No, I am not going to do hydroponics. When I lived in Texas, I had a hydroponic greenhouse, and I grew all my vegetables, all my food hydroponically in a place like Texas where it's hot in the summer and cold in the winter. By having a greenhouse and doing hydroponics, you can produce food year round. But if you're on the equator and it rains a lot, you have sun, you have rain, you have rich soil, why fool around with hydroponics? I grow organically, and I grow organically in the soil, and I am on the path to producing almost everything that I eat. I just started a rabbit project. I started with 10 rabbits. I'm up to like 60 rabbits, and I am building a big rabbit house. And what the goal is to have a rabbit operation that will produce every day 2 rabbits to eat. Okay, so we'll have 2 rabbits per day to eat. We have nut trees, we have fruit trees, we have gardens, and we have the most excellent river back there that we are not fishing in, but that will be the topic of a future project. Okay, so let's see if I can get over here, and enough of this personal nonsense talking, and let's see if I can get over here, and let's see if we can talk about good printing practices. Okay, first one was design things yourself. Now we're going to talk about good practices. The first thing is clean the bed every time before you print. Every single time before you print, clean the bed. Now, some people like to just use a little bit of a wet rag. Some people like to spray a little isopropyl on it. Some people say this is good, that's good. Figure out what for your bed is the best way to clean it, but clean it every time, because a little dust, a little oil from the fingertips, just any little thing on the surface of that print bed is going to make a very difficult problem even more difficult. So number one, always start with a clean bed. Number two is every single time level the bed. Okay, every single time level the bed. And now this is very important. So you clean the bed every time, you level the bed every time. Now this is something very important, and I think this is one of the most overlooked things that leads to people having problem with their 3D printer. And that is, don't try to compensate a misaligned printer by leveling the bed. Okay, so if you have a wonky printer and you are trying to correct the wonky alignment of your printer by aligning the print bed, you're just going to have nightmare after nightmare after nightmare. Your printer has to be properly aligned. And when your printer is properly aligned, you have to think of bed leveling. It's just the last little tweak. You're just tweaking it to try to get towards perfection. You're not trying to create this. You're not trying to correct this terrible misalignment by moving that bed to a strange shape. Okay, so this is what I want you to think about with the bed. All right, so I'm going to start over here. I think you guys can see it. Okay, so I'm going to start here and I'm going to draw the bed. Okay, and what you can see is this is what? This is flat and this is level. This is flat and this is level. This is what we call nirvana. Okay, nirvana. This is what you shoot for. This is what your goal is. But like nirvana, you're never going to get there. Okay, you are never going to get to perfectly flat and perfectly level. But what I want you to see as we are trying to understand this, what I want you to see is that there is a difference between flat and level. Okay, and now I can't draw perfect boxes. I can't draw perfect boxes at an angle with this, so now I'm just going to have to sketch. But if I kind of sketch something like this, this is what? This is perfectly flat, but it is not level. Okay, I could also draw something like this. Okay, what is that? What is that? That is level, but it is not flat. Okay, now, unfortunately, yeah, are you guys seeing? It'll help you get better prints if you understand and think in terms of the difference between level and flat. Okay, now the problem is, here is where most of you guys are. Okay, here is where most of you guys are. And I'm exaggerating a little bit, but here's where most of you guys are. You are not level and you are not flat. Okay, and a lot of times this is because your printer is not aligned correctly. And I am not talking about the position of the bed. I'm talking about the assembly of the printer. And so let me see if I can sort of show you what I am talking about. And we're going to talk about level right now. I'm not talking about the flat part, I'm talking about the level part. And so here is the problem. And I think maybe I should switch back over here to this view so you can see it. This is your X gantry. Okay, this is your X gantry across here. And what you need is, you need that X gantry to be perfectly horizontal, right? You want a perfect right angle between this and this, because if that gantry is like this, then what do you have to do to the bed? You got to try to torque that bed over to compensate for a misaligned gantry. And we can do some videos maybe later on, but one of the most important things for printing success is have your printer properly aligned. So if I look here, I want the distance between the X gantry to the top horizontal beam, the distance from here to here, to be the same as the distance from here to here. So if I put this ruler, what I can see is I am at 294 millimeters. If I come over here, I am at 295 millimeters. And that means the difference, the error, is 1 millimeter. Now, when I level the bed, how much compensation am I going to have to provide to get rid of that 1 millimeter? That's very acceptable, because if you look, really the effective movement of the bed that you can get is kind of maybe 5, maybe 10, but really like 5 millimeters. And so what you really, really want for success is you want this gantry error to be 1 millimeter or less. And you can go in and you can tweak that to get that aligned. When that is aligned properly, then your bed leveling becomes manageable and much more effective, and much more a solution that will actually lead to good prints. Okay, let me kind of show you what the problem is. Let me show you what the problem is if you're trying to fix a misaligned printer by moving the print bed around. And that is, let's say that we had the case of a 5 millimeter error in that gantry. Okay, the gantry has a 5 millimeter error. Okay, this is the gantry, and it is misaligned by 5 millimeters. What does that mean? The print bed is going to have to what? The print bed is going to have to be tilted over by how much? 5 millimeters. Okay, so it's going to have to be tipped by 5 millimeters, so these two are parallel. Does that make sense? Well, what does that mean? Like if I look at my knob over here, then this spring is way, way, way compressed, and then this spring out here is not compressed at all, and that is just not a good situation. That is not a good situation, because as you tighten this thing down, trying to get it down, what you can do is you can start introducing more bow into this plate, because you're pulling it down hard on one side and you're not pulling on the other. And if you're not careful, you can actually end up with a print bed that is looking something like, I didn't do that very well, something like this, where you are warping the print bed, pulling it down on one side and allowing it to go up on the other. And so even though this is kind of parallel, in trying to fix your flatness, in trying to fix your level problem, you're trying to fix level, you have generated a compounding flatness problem. You have generated a compounding flatness problem. I need to give myself a little more room here. Let's see, I think I'll go ahead and start a new drawing here. So what you don't want is, you don't want the springs on this side all compressed down and the springs on this side all up. That's very bad. It creates a lot of problems. Okay, so you really want to come in and you really want to align. You really want to align properly your X gantry. Does that make sense? You guys, let me know if this makes sense. The gantry does not have specific, like, tweak the gantry screws, but there's a process where you take the printer apart, you do some adjustments, you make your measurements, and then you lock it down. And I can go through that at some points to help you do that. Okay, Daniel is saying that makes sense. Good. All right, now this is the other problem. Okay, now I'm really now not talking so much about level, I'm talking about flatness. And here is something that you don't want to be. And this has to do with the Z-axis stop. Okay, what is the Z-axis stop? The Z-axis stop is this little switch down here. And that little switch, when it switches, then it says, okay, I'm at the home position. And on the Creality Ender 3 version 2, that has a little peg that comes out, so you just go down to the peg and then you tighten it, and then that's supposed to be the perfect position. But what happens is, it's not the perfect position. And if that stops the bed, if that puts the home position, too far up where the nozzle is here, okay, and that's too far up, then what do you have to do? You have to loosen these springs to try to get the bed to go up to the home position. And you don't want to be printing with loose, sloppy springs. You don't want to be printing where the bed is at the top of the spring travel. Why not? Because then it's not really stable. You know, it has an ability to kind of float around as you are printing. Does that make sense? Similarly, if your home position has the bed too high like this, okay, has the home position too high, now what do you have to do? You've got to really tighten these things down to try to bring the bed down. And then you're tightening them down so much, they're kind of like some mounts in the center. There are some mounts, underneath the center of the bed. And then what you end up doing is you can end up putting a cup into your bed because you've had to pull this down so hard in order to try and lower the bed. Okay, so what do you want to do? I broke that little knob off of the end switch, that little stop knob that makes the little switch sit down on the gantry. I broke that off so I can tweak the position of the stop switch up and down. I tweak the position of the stop switch up and down until what? Until I get a situation that when I level the bed, like if this was the sloppy position of the spring, the all the way up position of the spring, what I want is when I have it perfectly aligned that I have pulled the spring down about half. I've used about half the travel of the spring, and then my nozzle is just perfect and I am flat. So this amount of compression needs to match this amount of compression. How do I do that? By aligning the x-axis gantry, and then this amount and this amount needs to be by setting the position of that z-axis switch. Oh, I am not in my notes. Oh, how long have I not been there? Okay, so I am very, very sorry about that. Okay. Let's just see. I'm not sure how long I haven't been there, but here you don't want sloppy springs. You don't want sloppy springs. If your z-axis is wrong and you are too tight, that's not good. You cup it like this. And so what you want is you want to be in the middle of your springs where they're kind of like halfway compressed. And what we need is we need this compression to be the same as this compression. Okay, this compression is the same as this compression. How do we do that? By aligning our x-axis gantry. Then what I need is I need this amount to be half of what the total throw is. How do I do that? By adjusting the z-axis up and down, and then I end up not with nirvana, and I end up not with nirvana, but I end up as close as possible to something like this. Okay. And then I've got uniformity here. I am having a little trouble with Sketchbook here. Okay, so then I end up with about halfway compressed springs, compressed the same on both sides, and sort of halfway in the middle of what the travel would have been, the possible travel would have been. And then I am, wow! Hey, really appreciate that, Grathado. Really appreciate that. Helps me keep my high bandwidth connection, and helps me keep the generator running. Okay, so do you guys So give me some feedback. Do you see what I'm saying? The two big deals are you get your gantry aligned properly where it is horizontal, and then you get your Z axis where it puts the home position right in the middle of the spring adjustment underneath the bed. And then what? Then what do we do? Then what are these little knobs for? These little knobs are for the final tweaking. They are for the final tweaking. They're not to rack that thing over. They're just to tweak it to as close to perfection as you can get it. Okay, guys, give me feedback. Does it make sense what I am saying? Tell me, do you see what I'm saying? The reason so many of you are struggling is your Z-axis home is not correct and your gantry is not aligned, and therefore you are trying to correct a problem with the bed position that is beyond what the bed position alignment really does effectively. Okay, you guys give me some feedback here. I'm going to have a little go juice. Let's also look as I'm waiting. As I am waiting, let me look here. Yeah, you see the nut is now finished on our print. The nut is finished on our print, so that's good. And now it is over working on the bolt. It is working on the bolt. And I think that right now I can see if we can come back over to the river cam. Let's see what's going out on over on the river. Okay. There we got the river view. Maybe we'll see some fishermen here in a minute. Okay, I am not in Ghana. I am in Africa, in case you were wondering. Okay, Colin says it makes sense. The Wise Ninja, great info. I was thinking of getting a printer. Guy like you, Wise Ninja, you really need a printer. Hi, John. Welcome. Yeah, it's just like a CNC machine. It has to be lower part. Yeah, I think people that come from a machine shop or a machining world, they're already thinking like that. A guy that works in a machine shop already thinks about alignment and things like that. But those of us who are coming from the electronics world, we think about what? We think about plug and play. And that is, hey, fisherman, look at that. You guys see that? Fisherman. Fisherman. Guys, can I step us out for just a second? Like, give me 5 seconds. I want to align my camera. Okay, don't go away. I just got to align the river cam a little better. Okay, I'm back. Hope you don't mind. If I had someone in the control room, I could have them managing, but I like this view because maybe we can see some fishermen here. Okay, let's look at your it's the Creality Ender 3 version 2. Yes, that's what I have. Okay, I went fishing. Yeah, wouldn't it have been funny if you'd seen me kind of running out there and jumping in the fishing boat? I wonder how long you guys would have watched before you would have given up on me. Any problems? T3D printer transitioning from utility power to generator and vice versa? Yes. So I have problems because my electrical system here is very complicated. I'm running two parallel systems, a 240 volt sort of European African style electrical system in my compound, and then a parallel 120 volt American system. And all my houses and everything are wired up with two sets of plugs. You've got the European plugs and then you've got the American plugs, so I can run anything. And then partially, I have partial parts of the compound on battery backup. So if the grid goes down and I just want to work on the computer, or I want to work on, have the lights on, what I can do is I can operate off batteries, okay? But then the refrigerators and things like that won't work. So then what normally happens is when the grid goes down, the generator detects it, and then the generator will come on. And then that can cause different, it takes like maybe 60 seconds for everything to kind of get normalized and figure out where it is. And in that time, that's enough for my computer to crash, and that is enough for my 3D printer to crash. And so you would think that if I just had the generator on auto, that when the power went down, the generator would come on, and then in those 10 seconds I could operate through on battery. But it's just way more complicated than that. And so yeah, I have problems with glitches. And so like when I was printing something the other day, I really needed it printed. So I need to make sure that I didn't lose power, because if you're doing a 48-hour print, you don't want at the end of it to get a power glitch and things go down. And so what I had to do to make sure I could get that thing printed was run the generator. And the generator is like a 25 kilowatt commercial generator. And so, you know, that 3D print cost me like probably $200 in diesel to leave the generator running while I was doing the print. Yes, Ace Tool, I have a drone. You want to see it? You want to see the drone? You asked me for a drone. Hold on. Here's the drone. Okay. This is the new, what is this? This is the new Mavic or Magic or whatever it is, the new version, the 2. And so that's pretty cool. Okay, and I actually had it, yeah, it's a DJI. I actually had that where I could live stream from that. So like what I could do is I could send it out, and then I could get a feed. I could get a video feed back to my desktop. And so it might be nice to try to one morning do a live stream where you were getting a live view from the drone. And so I think that's cool. Let's see. Okay, Daniel's brother uses DJI. It's a good one. Hey, Texarkana. Okay, so there's some pretty good comments there. We got a nice audience today. Okay, so do you guys understand what I am saying? Number one, don't download and print someone else's designs. You design, you print. Design better, print print better, align your printer better. Okay, but the other thing that I would say is that yes, we are going to be upgrading our printers. We are going to be upgrading our printers as we go along. But a lot of times the first thing that people do is, oh, what is my problem? Bed leveling and bed flatness. I'm going to go out and I'm going to buy the little upgrade that auto levels the bed, and then I'm going to just not worry about it. That's not the right solution. Don't compensate a misaligned printer by trying to, basically what that's saying is I'm going to live with my bed. Can you guys see this? I'm going to live with my bed being like this, and then I'm going to have a little sensor that compensates it. No. Get your bed flat, and we'll talk about that. There's things you can do to improve flatness. Get your bed level. And then when you've reached that step, if you want to speed things up a little bit, then think about the upgrade. But the upgrade should be the icing on the cake. The auto leveling upgrade should be the icing on the cake. It shouldn't be the foundation of how you get prints, how you get the print to stick. It shouldn't be the foundation. It should be the icing on the cake after you get everything else done right. Yeah, there is so much on Thingiverse, but you're going to ruin your printer. You're really going to ruin your printer. You're never going to learn how to design, and you're never going to learn how to print. And I'll talk a little bit more about that. Okay, so let me talk about Thingiverse. First of all, if you download someone else's design and you press print, you learned what? Nothing. Absolutely nothing. And it's about learning and growing and developing skills that people will pay you for. I actually had a student in high school that went through my classes and learned how to design in Fusion 360 and learned how to print on the 3D printer. And then when he finished high school, he got into a little like searching for what he was doing in life. He didn't go to college. He kind of ended up in a little bit of a mess. And I think he went to Idaho or something like that. And he actually got a job in a machine shop because he could do Fusion 360 and he knew how to align things. And he is turning out to get a high-paying job because he developed skills that people are willing to pay for. And that's what I want. I want to show you guys skills that people will pay for. All right. And downloading something from Thingiverse is not something that anyone is going to pay you for. All right. So that's true. You need a good foundation. The good foundation on 3D printing is alignment. So besides just I have a conceptual problem with printing something you didn't design because you don't learn anything, but the other things are you see, it's easy to print small, simple things. Why? Because the reason it's easy is because even though your bed, you haven't gotten perfection in your bed yet, you can, where you are printing, sort of get things as good as you can in the small area that you're going to be printing in. And so printing small things are easier because at that small level, the bed looks flatter, if that makes sense. Okay, but if you're printing corner to corner, on the build plate, it's very, very hard because the lack of flatness and the lack of level are exaggerated. So if you're going to print corner to corner, you really, really have to have very, very good print skills and very, very good precision in your printer. But this is what happens when you download a big and tall thing from Thingiverse and intricate and try to print it. When it's big, it is harder to get it to stick down. Why? Because the lack of flatness is exaggerated over the extent of the print bed. Instead of having an error of 1/10 of a millimeter, you've got an error of 1 millimeter, and that is something that's going to cause an adhesion problem. Now, why is a tall print hard? Because as you print, the bed remains hot, but the upper layers, as they're getting further from the bed, become what? Cool. When things become cool, they contract. And as they contract, it's putting what kind of stress on the print? Up at the edges. And how does our peeling occur? You see the edges, they start coming loose, and then that curl increases, and then the thing pops off. Now, this is what happens. Okay, this is what happens if you guys can think about this. You download something big from Thingiverse, you print it, it starts out looking pretty good, then it comes to nighttime, you go to bed, and then it's printing over nighttime. As the night goes on, that curling stress is increasing, it pops off, and then the print nozzle knocks the print off the bed, and then as Vaughn was saying, you're now printing spaghetti. You're trying to print into thin air, and then that spaghetti becomes a glob, and that glob grows and grows and grows, and then the glob actually will come around, and it can actually encase or entrap like your wires, okay, like your wiring harness. And then also it finally gets so solid that the glob can't grow, and so you end up with filament in your hot end that has no place to go. Now, one thing that's going to go, your little drive gear is going to be sitting there, and it's just going to be chewing through your filament, and as it chews through the filament, it can kind of wear down, sort of smooth off those sharp edges on that filament drive gear, that filament drive mechanism. You're sort of wearing those sharp edges down. You're also filling the little gaps with filament, and then that entire drive mechanism is getting filled up with little filament powder. Now, what's happening over at the hot end, besides maybe encasing and damaging your wires, that filament glob that is trapped inside your hot end, it is sitting there with no place to go, and it becomes a different material. Okay, like it likes to get hot, it likes to get melted, it likes to get pushed through, but if it just sits there for an hour or two in that hot end, it becomes carbonized and it becomes a different material, not like a nice, a nice well-behaved plastic. It becomes like a hard rock inside your nozzle. Now, certainly your nozzle is clogged at this point. You get the whole glob off of it. You damage the wires in doing it, and then you get a new wiring harness. You put the new wiring harness on, and now your nozzle is completely clogged. All right, you get the little tool. I think I've got the little tool here. Let's see. Yeah, you get the little tool here, and you heat up the hot end, and then you clean the nozzle. Okay, you clean the nozzle, and then you go, but your printer just never quite prints the same again. And you know why? Because what you have now is a partially clogged nozzle. You got it cleaned out to the point that you can pass filament, but somewhere up in there are little gritty, rough places of that carbonized filament along the inner wall of the extruder, and it doesn't allow the filament to extrude smoothly and cleanly. And that is the reason most people end up throwing out their printer, is because they clean the print head, they level the bed, and they can't ever get it to print reliably again. Why? Because you have a partially clogged nozzle. Now, this is what you should do. Yeah, hot appliance running unattended is not for me. That is a good rule to live by. I believe we got some fishermen way back there. We got some fishermen way back there. So what you want to do is, and this is kind of a tip, so do you see why you don't want to print things from Thingiverse? That when you have this happen, it's very, very hard to ever get your printer where it's working correctly again. But there is another reason not to download things from Thingiverse, and that is they can have STL errors. It's not a perfectly closed, verified STL file, and when you try to print it, it can confuse the printer and it can lead to failed prints that then cause the same problem that I had just told you. It is very important for you to print what you design and for you to design things with proper STL files. Now, Fusion 360 generates correct, proper, closed, complete STL files, and they will not have STL errors in them. All right, but people who are more artistic like to work in Blender. Guys, Blender is an art program. It is not an engineering program. And the STL files that are generated by Blender are notoriously corrupt, incomplete, open polygons, unfinished meshes, unfinished surfaces, all this. And you go in and try to print them, you might be able to get them sliced, but then you're going to have errors and problems as you try to print them, and those problems could damage your printer. They could damage your printer. So let me also say that the two things that I would never print anything that was designed in Blender or SketchUp. Before I learned Fusion 360, I learned SketchUp. SketchUp produces horrible STL files. Never print anything from SketchUp. Never print anything from Blender. All right, now I know some of you, I haven't been watching the comments, but if you haven't said, if no one said it already, someone's probably thinking it. Oh, well, there's this net repair program and it'll fix your STL files. Guys, you don't do it that way. You don't write corrupted STL files and then try to correct them. What you do is you create proper STL files by using Fusion 360, just like you don't try to compensate for a badly misaligned print bed. Okay, but this is like life of most people. You have corrupted STL files that you're trying to print on a misaligned printer. It's just never going to work. And so, guys, I hope this makes sense. Let's look at some of your comments now. Yeah, it does smell bad if you clog it and let it sit and bake the filament. It can cause a problem. Yeah, Best thing is to not leave your printer unattended. Kind of like on the long ones, I have to. But what I do pay attention to, the Ender has the resume feature, but that resume feature only works if it's restarted fairly quickly before the thing pops off the bed. But really, the best thing is, if you at all can, is to sit and watch your your prints and not leave them unattended. Okay, let's see. Maybe you could design an Arduino that senses an error in the print and turns the machine off. Yeah, I think that it would be really neat to do something where you could at least stop or abort the print if you're air printing, and that way you lose the print but you don't damage the printer. And I think that should be pretty good. Yeah, I think at the end of the day, don't use Thingiverse. I really think that that's true. And if I saw a cool idea on Thingiverse, I really don't go there, but if I saw a cool idea there, I would go out and I would design the thing up in 360 myself, because then I might actually learn something. Okay. Is FreeCAD a decent alternative to Fusion 360? I've looked at FreeCAD, but the problem is it kind of has this not ready for prime time feel to it. And it's sort of like it's not consistent in the different parts of the program and in the different menus. Like one guy wrote this and is calling things one thing. And over on this other menu, another guy wrote this and he's thinking about it and calling it differently. And so just the terms and the nomenclature between different parts of the program confuses me. It's sort of like, looks very much like the open source software that it is. And therefore that inconsistent use of terminology and techniques between different parts of the program confused me. And I really tried to make it work, but I just came away like, if I cannot understand it better than this, I could certainly not teach it to anyone. Also, guys, this is just my own personal opinion. You can hear me coughing a little bit. I try to not breathe the fumes that are coming off with 3D printing. You can smell it. And that smell is some chemical, and I don't know what that chemical is. So in general, I try to not breathe the fumes that are coming off the 3D printer. Right now, I don't really have much of a choice. I don't have much of a choice because I'm sitting here in front of it, but really use good ventilation. And I would not like to live in a room that was constantly having these fumes come off of the printer. Okay, let's see. Yeah, Fusion is free for hobby use. Carbon fiber, I have not tried that yet, but I will. I have ordered some other types of printer, printer filament. And what I think is PLA, PLA is the easiest to print with, but it doesn't create the strongest parts. And so like printing in nylon or printing in other things can give you better prints. But remember what I said, we're going to build our print skills gradually, and you don't want to jump in and the first thing that you do is try to print something in nylon. Okay, you want to develop those print skills, and when you're really the master printer, then start looking at some of these more difficult filaments to print in. All right. The Fusion 360, there's a free version, so look at that. Yeah, Pascal, you're right. Don't breathe the fumes. That's really true. Small carbon filter and fan would help the smell. Pretty cheap on eBay. Yeah, you could try to filter it and stuff, but I'm just in general wanting to not breathe it. How about that? Okay, chocolate filament. I have really always dreamed of printing in chocolate. You will not have a chocolate filament. You cannot drive chocolate through, chocolate is gooey and crumbly. But the way you would do it is you would get a syringe, like imagine a syringe that is this big around and that tall, and then the syringe would have kind of a big needle, and that would be mounted here at the hot end. Then you have a heater in the syringe, so you just put the chocolate chunks in the syringe, okay, and then the heater in the syringe melts the melts the chocolate, and then the plunger is driven by a screw. So you're very slowly turning that screw, and it's very slowly pressing the plunger down, and that is very slowly extruding the chocolate. Now, what I would think is, I would think you would want to print very slowly, and I would think you might not want a heated print bed, because you would want that, and you would probably want a fan on your print surface, because you would want that chocolate to re-solidify quickly. The filament has a high melting temperature, it solidifies quickly. Chocolate has a low melting temperature, it would solidify slowly. But in my mind, I have always wanted to 3D print food. So maybe one day I will do a project like that. Okay, so let's see. I'll talk a little more, and then we will have a. I wonder how long. Oh man, we have gone long on this. We've gone long on this. Let me kind of wrap up with a couple of points here. Let me wrap up with a couple of points. I will come back over here, see if we can. Fisherman way up there. Okay, looks like Island Girl is not out yet. Island Boy is not out yet, but we got a few fishermen in the background. Okay, let me talk about a couple of things now. Printer upgrades. I would not start with upgrading the printer. I would start by aligning the printer I have, because sometimes we have a mindset, well, if I just bought something, it would make my life easier. But buying something will not overcome the fact that you have not properly aligned the printer. So I would start by aligning my printer as good as I could. I would start by trying to get the bed flat. I know that a lot of people, I'd meant to talk about this earlier, but a lot of people have sort of a U-shaped bed. It's shaped like this, U-shaped, it's not flat. And what people have found is, if you put a piece of paper underneath the glass part of the bed, and then you put a piece of paper under the center part, and then if you put strong clips on the outer part, you can kind of take a little of that bend out. Doing things like that, doing things like aligning your x-axis gantry, those are the first things that you should those are the first thing that you should do. Now, when you do come to upgrades, I would not start by that auto bed leveling thing. That's what everyone wants to get, the auto bed leveling thing. I would not start with that. The first thing I would start with is a pack of spare nozzles. And if you look on Amazon, you can get like a dozen spare nozzles for not much money, like maybe 15 bucks or 20 bucks. And I like to have those spare nozzles. And that way, if I think I might have a clog, or I think I might have a partial clog, first thing I'll do is just take the nozzle off, throw it away. I don't try to salvage it. I throw it away. I put a new nozzle in there. And that gets rid of about half of the problems I have with 3D printers. I like having extra nozzles. Oh, we got some great fishermen. We got some great fishermen there. You guys see that? I like to start with clean nozzles. And so the good thing is, the upgrades that you need to do first are really the cheapest ones. And if you guys will play along with me in my class, I will be doing upgrades as we go along. So don't go out and just buy a whole bunch of upgrades. I'm going to show you the cheapest upgrades that you can do that will give you the maximum bang for the buck, which might be like a $5 upgrade or a $10 upgrade, and I will be taking you through those. The other is the springs that are underneath the bed. They're kind of flimsy, cheapo springs. I like to upgrade those springs. And then in the thing that drives the filament, I like to upgrade that with a stronger spring, because I want to really have force to really push that filament. I really want to have that snug, so I like a stronger spring there, and maybe like upgrade that little drive mechanism that pushes the filament. We're talking about $3 and $4 and $5 upgrades here. And so what I would recommend for you is, I would recommend that you go through this with me, and not just run out and start buying a whole bunch of stuff. That you would go through it with me, and I'll take you step by step through it. One of the last upgrades that we would do, yeah, 2 fisher boats, each with 2 fishermen. If Top Tech Boy sees 2 fishing boats and each fishing boat has 2 fishermen, how many fishermen do we see, right? It's like a math problem. Okay, but I love it every morning, just being able to look out and see the fishermen going out about their business. But one of the last upgrade that I would do is the auto bed leveler, and I would only do that after I had everything almost perfectly, and then that's something that would just make my life a little easier. John says, I added glass on the hotbed. Best thing I ever did, got glass from an old scanner. Yeah, and a lot of the printers come with glass, and glass is, starting with a good mechanically closer to flat bed is a good thing to do, and those usually don't cost very much either. Wow, Kevin, thank you. Did you guys see I have my little thank you bell? Give a big thank you to Kevin. Man, guys, really, I do appreciate it. And I know a lot of you guys are also supporting me on Patreon and, using my affiliate links. You guys, if you want to help me when you buy your filament, use the link in my Fusion 360 lessons. And that just helps me, right? It helps me with things like keeping a fast internet connection, being able to come to you with a live stream where I'm running an enormous commercial generator in the background. It just sort of helps me bring you a better product. So really appreciate the help and encouragement that you guys are giving me. But I think the best upgrades to the printer are often the cheapest updates to the printer, and that's what we're going to be doing. And kind of like the last one will be the auto bed leveling, and that's kind of, again, it's the icing on the cake. It is not the foundation. There is one that we will do before that, and this one would probably be about a $30 upgrade. But what that is, you see how you have your Z-axis driving screw over here that makes it move up and down, and then this is just kind of floating over here. You add a second Z-axis drive threaded rod here, and so you have a motor on this side and a motor on that side, and that way the motors sort of move it up and down, and that keeps your gantry horizontal, which really makes life a whole lot easier. And so that will be one of the upgrades that we are going to be doing as well. So we'll be talking about that. So let me take like maybe 3-4 minutes to answer questions, look at your comments, interact with you a little bit. I'm really sorry that we've gone over. It's just been so long since we had a live stream. We had a lot to talk about. One thing is, leave your comments in the chat here. I'll interact with you a little bit. Let me know, would you guys be interested in having more live stream, or is one every 6 months about right? Let me know, because I don't want to do live streams because they're a lot of work if you guys don't enjoy them and if you're not going to tune in. But if you enjoy them and want to see them, let me know. So let me interact with you a little bit here. The magnetic bed with the tech build plate is okay. That I agree, Kevin. That is, I think it was a Prusa that I had that had the magnetic bed. It had the auto level, and probably the Prusa was one of my favorite printers that I ever got. Now, why did I not recommend the Prusa to you? Because it's very expensive, and you learn more with a cheap printer. Okay, and so with the Creality printer, we can tweak this thing and we can develop skills, and we can get just as good of a performance as you can get with any of those expensive printers. But what's the difference? You learn more. Okay, but I agree, the magnetic bed with the high-tech surface is a good choice. Let's see. Take care, everyone. Vaughn, appreciate it. Thanks for tuning in, Vaughn. Thanks for being a moderator. Hope you guys, hope people were well behaved. I was not able to see all of the comments as they were coming in the chat. I truck 12 hours a day and study your classes for 3. It's hey, great. I like it. You know what I look at something, this channel, sometimes it's like a little stain. It's a little corner of sanity in an insane world, right? It's like us people that are still sane, we need to get together and sort of have a little safe place of sanity, because it seems like the world is really getting crazy. And so I do I do really enjoy. I enjoy this channel, and I enjoy the audience because it seems like in a crazy world, we have somehow managed to find a group of nice, polite, respectful, and smart people that are actually doing good things. Okay, I missed the joke, and so I'm sorry I missed the joke. Raspberry Pi Octoprint. That would be, whoa, John. Appreciate that. Hey, you guys are really being generous here. I appreciate it. Okay. Let's see man, I am behind on the comments. What math classes should I perfect for electrical engineering? Number one, master algebra. Algebra 1, Algebra 2. After you've mastered algebra, master trigonometry. And then after trigonometry, master calculus. The good thing is math is fun and easy, and so those are the things that you really want to perfect. Okay, learning from you, I'll put up watch it. Okay, my 3D print is almost done. Hey, Brian's 3D printing. Good deal. Brian is resurrecting that printer. Okay, everyone was well behaved since Charlotte wasn't here. That's funny, Daniel. Okay, let's see. Roe versus Wade. Okay, well, I should go. Have a good day. All right, it looks like we're kind of wrapping things up here. So, guys, really appreciate you tuning in. If you like this, after the live chat, go to the video. Make sure you give us a thumbs up. Okay, let's see. We've got 123 viewers and 67 likes. Where's the love? Where's the love here? 120 viewers and 67 likes. Come on, guys, hook a brother up with a like. Also, the likes really help me. If you haven't subscribed to the channel already, make sure that you subscribe, and then leave a comment, not just the chat, but go to the comments, leave a comment, because that helps me with the old YouTube juice. Because why? Because YouTube will show this video, show this live stream to more people. Why is that good? Because the world needs more people doing engineering and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.